Greetings and happy Pi Day! This year I decided to compute pi without the aid of a computer. I printed this grid, which is made in LaTeX and, well, may be considered to be somewhat of a computer aid, and then I borrowed these d10s from a bunch of local nodes. Consider a square with an inscribed circle. If the square is the Cartesian product of the interval 1, 100 with itself, a point inside the square is represented with two real numbers, each between 1 and 100. If we choose a point at random uniformly in the square, how likely is it that it will be inside the circle? Well, the probability of it being inside the circle is given by the fraction of the area that the circle occupies. The area of the circle divided by the whole area of the square tells us that the probability is pi divided by 4. Therefore, if we take a bunch of points at random in the square, the fraction of points inside the circle should tend to pi divided by 4 as the number of points increase. Now, we work with an integer approximation of the situation we just described. Instead of a square with uncountably many points in it, we have a big old grid. Rolling a pair of these dice gives us a number from 0 to 99. Rolling 4 dice gives us two numbers, each from 0 to 99. I used the dark dice for choosing a row in the grid, and the yellow dice for choosing a column. Then I colored in the intersection. I repeated the process 50 times. At the end, we found out that, at least for this year, the official value of pi is 2.88. Well, this is not great. I guess 50 samples was not enough. The thing is, why bother dealing with paper, ink, and nerds if we can just write a Python script to do the math and the visualization? So, here it is. It generates some lines of ticks that I can add to my original LaTeX file, and also computes the value of pi. Now for the results. With 1000 points, we get a value of pi around 3.17, which is not bad, better than before, but still, it's not great. With a sample size of 10,000, we get a value of pi around 3.15. If we add another order of magnitude, LaTeX does not render, it fails, because it's too much. And yeah, so that's all for now. I'll see you in the next video.